folks, it's me again. Today we're going to be talking about all the reply I have from the last video about the small machine here, I call the voodoo machine. And it was lots of good comment, a lot of people, you know, they're putting some thought into it, which is good. I have a couple who actually are very close to what's happening with the machine. They're, you know, they've been following that and what's going on and stuff like that. So, and I got one of the men, his name, he calls himself Cowboy. He's probably the closest one what is going on. He's been studying Tesla for a long time, and he know exactly what I'm talking when I said resonance is not a frequency. You know, it's all about resonance. So, and I have also another one who comment about, and this was a small comment, and he says, and he was saying it was, you know, it seemed to be like the spar gap, or, you know, it seemed to be something's happening in the spar gap. And it's very interesting because, yeah, the spar gap is the magic box for Tesla. You know, if we wouldn't wait for the spar gap, we wouldn't be able to turn the light on the wall. And also I find out with all, you know, through over 200 so far of comment on my video, you know, it's amazing how many people who doesn't really know how the power is distributed. Everybody's using it. Everybody turn the switch, the light goes on, they know it's working, the light doesn't go on, something is wrong. But no one knows exactly how it's distributed, how it's manufactured, how it's distributed, and how you get it into your house. Well, no one really want to tell you that. I spent 2.5 years digging into that stuff, and then to break down what's coming on. Well, we all know AC currents, like I'm talking about AC currents for everybody there, cannot be transmitted in a long distance. It dies. Just take the heavy extension cord you have and put 300 feet of it and see how much volt you got in the end, right? If they would transmit AC currents, the cable would be about 4 feet across to be able to carry the AC for a longer distance. It's ridiculous. So it cannot be AC. AC is manufactured into the transformer, the pole transformer, the street transformer. That's how your AC is manufactured. But what is coming into the line cannot be AC. But everybody's, well, it's got 60 hertz. Yes, but hertz only apply for signal. Hertz do not apply for a slash. So instead saying we have 60 hertz coming out on the top of the line, right? It's 60 slash. That's mean, my friend, go into your binary. Zeros and one. It's on, it's off. It's on, it's off. Now you have a massive generator who's turning, which I was looking at one getting rewind last week, which is about 30 foot across, 440 coil on that stator. And then I'm thinking about it. I said, holy shit. I said, this is like an inverter. And it's exactly like an inverter. And the reason it's like an inverter because that's the only way you can create high frequency, multiple head. More head you got, higher the frequency you're going to have into your output of your generator. Now you're saying, oh, now it's not talking about resonance. I said, I'm not talking about resonance. I'm talking about frequency. Frequency is a signal, right? This generator, when it's when it's engaged and it's spinning, is creating high voltage because all the volt, they're all connected in series. So all the volt multiply or add themselves to the next one, but the wave, you know, or the signals coming out of that generator, it will be an AC wave. It will be tight because it will be a lot of it, and then what's happening when you have that kind of frequency coming out with the high volt, then you can do a lot of stuff with it, right? Now it goes into, I would say, pretty much a step-up transformer, probably to crank up the voltage even higher, and then it probably go through also a set of spark gap because you gotta break that down so you can actually create potential. So your potential coming on your line have to be resonance into your line, or high frequency if you want to call it that way. And then you slash it. A slash, that means it will be a burst of energy. Let's, for example, let's put a number on it. 1 foot long burst. But it will be a 1 foot long of nothing, 0. 1 foot burst of high frequency, high voltage, and then again 0. That's called boundary. Zeros and 1. That's how your calculator, that's how your computer works. That's all data transfer. Zeros and 1, no different. It's switch on, switch off, switch on, switch off. So that's why it doesn't create a signal. That can be transferred on a line far, far away. I mean, we're talking about 300 mile plus on a line. And a Tesla was able to do that also by air. And we're doing it every day. Every time you use your phone, your cellular phone, you're transmitting energy through air. So I mean, it's not a mystery. We've been using, everybody's using Tesla's technology, but no one knows how it works. This is very interesting. But I mean, I really enjoy all the comment, because it just gave me a picture of how the world see things. Because I have to find out how you see things, because a lot of people don't see things the way I see it, and they still cannot explain how their light turns on when you turn the switch on. They don't know. They don't have a clue. They're clueless. But I mean, like, you know, that's what I'm making. Now we're going to go. I'm going to go try to explain every number coming out of this unit, and I will show you the level of multiplication and amplification and magnification the 2-spark gap does, and it will be all on number, all on the instrument, and all done properly, so all you folks can understand what is going in with the loop motor. I don't give a shit about that. It could be an hamster wheel here with a hamster in it. I don't give a damn, right? I'm interested in what's coming out of that and what it creates here. Let's not lose the focus from, you know, from the guys trying to start this car next door here. Let's stick with this here, all right? So we're going to reset ourselves up, and I'm going to show you some number, all right? Thank you. All right, so now we're going to do some testing, see how much volts coming up from low RPM to maximum RPM, so we know we have a maximum on it. So I got the meter connected here. Let's see what we got here. That's maximum, that's minimum. There we go. As you can see, the volts right now. Now I'm going to bring to maximum, so everybody will know how much I'm putting into the transformer. 240, you know, I call it 250. So, all right, now we're going to put the meter on the hertz, so we know exactly how many hertz is going into that. Okay, so now we're on hertz. Let's see what is going to happen. I got 0 hertz. Hang on. Why everything is going sideways here? Let me see if I can do that like this. Oh, there we go. At maximum RPM, I'm getting 350 hertz, 360 hertz. As you can tell, the hertz goes down as I bring the RPM down. All right, so now we know that we have that much hertz. So iron core transformer, the maximum they will take is 150 hertz. So we know we're into the hertz necessary for the transformer to operate it properly. So now we got that out of the way. Okay. Now we're going to do another test. I'm going to move that here so I can put the instrument on it. I'm going to bring that here, and I'm going to put my little coil. So we can read some of the hertz also coming up. Okay, so I'm going to try to find the hertz what's coming out of here. Low RP. Oh, I'm going to put that on here. So I'm getting about, it jumped between 10 kilohertz, sometimes all the way up to 20 kilohertz coming out of the coil. It's not steady because the spark, they don't react always the same. Now, I'm going to show you another one. It's still reading a little bit. Now this is a tri-field smart multimeter, EMF meter. It will give you 4 readings. One is your magnetic field, plus underneath there you will see X, Y, Z, right? So it tells you if your field is in 3 dimensions. And then you will have your electrical field, which is normal what we feel right now, 8, you know. And then also your RF strength, which is give you a perfect showing how it's coming out. Now, I'm going to bring that thing here. As you can see, look at the number going up. Look at the number going up on the coil. It will go, you know, most of the time he hit 1,000 on the volt. Here we go, 1,100, 1,400. And you can see the graph here. On my X, I got 4.16. My Y, I got 5.14. And Z, I got 0.29. That means I have dimension. So I'm 1,500 volt per meter. Now I'm going to stop it, right? And it's all going to go down to normal. The coil is discharging. You know, that's just like a choke coil. You know, when I said a coil, I'm talking about this here. This is what I'm talking about. It's just the end of a 6,000 primary from a 6,000 volt step-up transformer, 120 to 6,000 volt. Now I'm going to disconnect. I'm going to remove the spark gap. See, I'm disconnecting the spark gap here, and I'm going to disconnect the spark gap there, and I'm going to reconnect that with that spark gap. When people said, "Where's your proof of amplification? Where's my proof of amplification?" If people would have built a machine like this, they wouldn't know where the proof of amplification is. But most people, they don't want to build nothing. They just want to sit and talk. Well, I like to do that too, but sooner or later you got to stick together. I mean, like science it's not writing stuff on the whiteboard. Science is putting things together and testing and finding out how many times can we duplicate that. Now see, it's not connected. It's totally disconnected. The spark gaps are no longer in the equipment. Only the bulb. What's going on with that bulb? I don't know. Your guess is just as good as mine on that one. But you will see the difference here. If we go back to what is going on here, let's start out again. That's maximum. That's it, folks. That's what you're going to get in maximum. The volt will never exceed 60 volts on the output, on the electrical field. And you will see the difference how low my magnetic field is. And you will see how low my RF strength is. Even on the X, Y, Z, it changed. As you can see the number. Now I'm going to quickly reconnect the spark gap. Let's go back to the meter again. So everything is connected back to normal with a spark gap. Look at that. It jumped 1,600 volt per meter, and now it's distorting my screen. It's so strong. Look at that. Now, the spark gap does that. Look at the string, the RF string is just crazy. 1100, 1300. There you go. Now my screen is getting a beat up. So, I mean, like, you know, those are numbers. They're actual, you know, real numbers. Now, if anybody, now they want to tell me, you know, what's going on by the multiplication if it's not resonance, because you have to understand, you can push right an electron through a wire or around a wire, but you cannot have electron floating around you. They don't work that way. It's all about resonance. Everything in this world is about resonance. The electrons, like I said before, here's a big chunk of electrons. It's called iron electrons. They've been cleaned up from all the other electrons, from all the other garbage that was in there, from the other material, and they try to bring it as pure as possible. And this is just a core, an iron core. So that's iron electrons, all put together and cleaned up. Now, no one is talking. And all the field I've been looking, and everybody, no one is talking about, what about the electron, aluminum electron, copper electron, plastic electron, and what about else? It's got electrons. There's tons of shit that's got electrons, and they don't float up in the air. Because if you were floating, all the electron floating in the air, your ass be floating also. You wouldn't be able to keep your feet on the ground. So now, if everybody want to put their thinking cap now and think straight, and if you can't, prove is fact. Right? That's what you guys telling me. Prove is fact. This is proof and this is fact. Right? So I want you now to think about how all your little book in university tells you how the electron work. Because if you follow that book, you will never be able to light up your own house. But we've been using the technology from Tesla and no one knows about it. Everybody's talking out of their ass about, oh, this power here, this power there. But no one can explain when you turn the switch of their house on and the light comes on, why it all happened. It's a big fucking mystery. And we've been looking for the mystery for 100 years. But no one want to show you or want to tell you how they actually do it in a power plant. I guarantee you, matter of fact, here's a challenge for any power plant company. I like to have a tour for one day and their power plant and walk through it.
With a camera.
With a camera. So I can put that in a video. I would love to do that because they have so many secrets, so many lies. You know, like here, for example, you say, well, you got a loop. It's a loop. Well, guess what? Wake up and smell the coffee. Your whole fucking power grid, it's a loop. What happened with the loop break and one of the grid? Shit hit the fan, innit? Because the power cannot return to the company. Because it's called pressure. High voltage, high resonance, high potential with a slash. It's a tremendous amounts of pressure. So that's why when you touch the top line, you will vaporize. But if you touch the neutral line, you don't feel nothing. Guess what? Tons of thousands of volts going through that line, but you don't feel it because it's under a vacuum, not a pressure system. That's mean vacuum, the sucking power into it. That's mean at the factory, they create a larger demand. So they can recycle that power so they don't have to manufacture all the time. That's how they expand. When your generator's not big enough, you got to save all the little bits. It's like walking around with a bucket full of water with holes in it. By the time you get to where you're supposed to go with the bucket of water is only a quarter full. So you have to stop saying, I got to patch some hole here. So I get a full bucket by the time I get over there. So that's what they're doing it. That's what, before we didn't have a return line. We didn't have a neutral line. It was only one power line. The neutral was the ground and the earth. No, we don't have that. Everything have to come out of your house and go right back. A pole transformer is just an open and closed gate. When you turn something out, the gate gets open and then flow goes through your house. It operates the equipment, and soon as you finish operating the equipment, it goes back into the return line or the neutral line, and back to the factory it goes.
So maybe you have a bit of an update from the Earth Energy.
Oh, absolutely. I got an excellent little video. Actually, we should put that video on, if we can.
have to ask permission.
Yeah, oh yeah, absolutely. Someone is actually doing some test, building something, and that's the lab we have from Natural Energy in the States. So we finally got our electronic guy there, and one of the worker and the owner of the place. They're doing a fantastic job. They have a beautiful lab, like a building to build the lab as the lab will grow. And those guys are go-getters, so I really enjoyed the video today. I just saw it this morning, so it's great. But I will give you some information.
Yeah, I just wanted to show you we got this thing together, and I tested out, and it's running pretty good. I'll go ahead and turn it on and show you what it's doing. It's pretty cool. That's a tri-field meter. It's putting out quite a bit of radio frequency. If I switch it over here and go, you can see it's quite an electric field. It's got a really big magnetic field, and that's just a coil I made. It's a bifiller coil, the same coil that's in the induction cook stove, so I just made one that works pretty good. I can show you the little LEDs that I brought with me. I made another little coil for it, and I can show you just kind of couples with it. So if I put it on there, it'll light up. Hey Bob, say hi.
Hi. Show our scope.
Oh, here's a new scope too. It works pretty good. It's cool. Give me 1 second, it's booting up.
It's a good deal, yo.
See, there's the wave. It's just a test thing for the side there, but it's just showing it's working and everything. Works pretty good. It's cool. Thank you. But yeah, I'll turn this thing back on and I'll show you that it's working. And just stick this on top of there. No wire attachments. And it'll light up this LED. There you go, you have it. Yeah, I just want to show you what we've got done today. Charlie brought this in here and he is setting it up, and this is a little deal that he kind of used to couple it. He's got this little plastic deal under here. Just kind of sits under there, and then he's got the little plastic deal here, which both of the things come together, and he's got it coupled there with a little coupler that he machined out. It looks really good. It doesn't move at all. You can try and move it and it don't move at all. It's cool. But yeah, pretty cool stuff. Alright, bye.
We're still waiting on the wire, and that's another thing I like to say. Anybody who's tried to make power, and I you know, if I hate to say that, but if you try to make low voltage to supply low voltage system, right? It's like putting the brakes. Soon you're going to put a load on that generator, on your demand on your house. You can turning the oven on, or the hot tank, the water kicks in. That sucker will die. That's the reason. Oh yeah, because it puts the brake on the generator. That's why the generator, you get a big diesel motor, and if you demand too much out of it, that motor is just sucking the fuel like crazy. Hey, it's not a mystery. Get out of your house, go and take a look at a generator, how it works, you know? So it's that simple. You cannot do something to run your house if you're creating low voltage to feed low voltage. You have to create a generator to produce at least 16,000 volts at high frequency. That's mean high, you know, as high as you can. And like again, I believe those top line, they have 55 kilohertz of frequency into it between, you know, between the slash. So that would mean that's what you really have to accomplish. You can accomplish on a smaller size. You don't need a big multi-trillion dollars dam to power one house. We can, as long as we got the voltage high enough to operate the pole transformer properly, which you need a minimum of 14,400 volts. So you dump in 16,000 volts in it. It will raise your voltage into 120 to 130, which is much better, because it was a system, it was 132 volts, and they took away, but it costs nothing to run stuff on it. Your equipment runs way cooler and much better, and it lasts longer. So, I mean, like, all you gotta do, literally, is just study the real thing. You know, go to the old archive. Stuff they don't give you that in school. I mean, like, you know, it's just a brainwash what they give you, because, you know, if you apply what the book says, you know, you can never duplicate that on practical. Practicality is what you can put something together and connect it. Either it works or it doesn't work. Either it burns or doesn't burn. Either it blows or doesn't blows. That's what R&D is all about. I mean, like, you know, you don't see any whiteboard around me. I got one, someone sent me, and it's beside beside the stove over there. I mean, my freezer over there. I don't write anything down, for the reason is, it's a waste of time. Run it into your head for a couple of days. I mean, just run it into your head for a couple of days, and if it's work, it makes logical sense, not bullshit sense. You have to be logical. You have to be totally logical when you work with this system, because anything else, if you don't use logic, anything else fail. And it's been proven. Look, I mean, we have all those great men, Tom Bearden, right? That was one of the best scientists in North America. We're having, what's the other guy? Is sick, is in hospital, I heard. We've been talking about the same stuff, right? We have to be able to take the blind off our eyes and see what is around you. And believe me, electrons don't fly. So we're just going to cut it there, and hopefully I'll have some more news with the wire, so we can get this generator to 60,000 volt. If it doesn't work very fast, I'm building another generator, a different one.
But others are working on them in other places.
Oh, absolutely. Yeah, other people are working on that in another place. So if I cannot accomplish to get the wire I want, I'm going to create another generator which will give me the same frequency I'm requiring to be able to run a house at high. And the thing is, the whole system will run probably on 10 amp. And you will be able to push the pole out of that 10 amp 250 amp at 240. I mean, like, you know, this thing run by itself. I mean, after you energize everything up and everything's in motion, you have no problem. So, and bearing, it won't be a problem, because I already designed my own magnetic bearings. I mean, all those companies who have magnetic bearings, you know, they're crazy the price they want to charge for that. It's very simple. It's a very simple task. You know, you just have to know how to do it. So, most of our bearing, after we finish doing the test with the regular bearing, I'm putting my own magnetic bearing in it. So we will have, you know, no friction, no drag, no noise, no vibration whatsoever. It will be totally silent. So, but yeah, that's about it for now. And hopefully the next couple of weeks I'll have an update, and we'll see you then.